Hello everyone. Today we are going to discuss about depth first search and breadth first search. That is one of the very important graph traversal concept. Let's look at that. Understanding two fundamental graph traversal algorithms. That's our aim today. When we consider breadth first search and depth first search, we can abbreviate it as BFS and DFS. Let's compare them and try to understand the basic concepts. BFS, it is starting with the source node and goes layer by layer from source node to the layer 1, left node, and from left node to the right node, one by one. After that, it is going from the next layer, leftmost node, and then it will goes from leftmost node to the rightmost node. That's how it's doing that task. Other than that, when you consider how the output is generating, so the BFS is starting with the value 0 in this example, then it goes to value 1, then 2, 3. After that, it goes to the value 4, 5, 6, 7. That's how it's generating the output in breadth first search. Then now let's consider the depth first search. In the depth first search, we are starting with the source node and it goes to the left branch. It's completing the left branch completely. After that goes to whatever the middle branch or branches and complete them one by one. And after that it goes to the right branch. Now let's see how it's generating the output. It first get the value 0, 1, after that 4, then it's complete in the leftmost branch. So number 5, then it goes to the source node and again goes to the value 2, 6, and again it goes to the source node and access value 3 and 7. That's how depth first search output the values. Now you have a clear idea about BFS and DFS, how it's traversing and how it's outputting values. Now let's go to the descriptions regarding these things. So what is DFS? It explores as far as possible along one branch before backtracking. It is the approach is deep exploration before moving to another branch. Data structures we can apply for the stacks via recursion or explicit stack. Order of traversal node, child, grandchild, backtrack. What are the example users? Maze solving, cycle detection graphs, topological sorting, that kind of situations we use DFS. Pros and cons of DFS. The pros are use less memory in sparse graphs, can find a path without exploring the entire graph. Cons would be may get stuck in deep or infinite paths, doesn't guarantee shortest path. So what is this BFS? Explores all nodes at the current depth before moving deeper. Approach is level by level exploration from the starting point. Data structure queue. Order of traversal start node, all neighbors and neighbors of the neighbors, like that. Example users shortest path in unweighted graphs, social network, friend recommendations, web crawling. What are the pros and cons of BFS? Pros would be finds the shortest path in unweighted graphs, ideal when nearest solutions are perfect. Cons would be requires more memory, stores all nodes at a given level. Now let's compare these two and see DFS, BFS, and the feature exploration style. DFS deep before backtracking, BFS level by level. Data structure DFS stack, BFS queue, Memory usage DFS lower in sparse graphs, BFS higher. Shortest path DFS not guaranteed, BFS guaranteed unweighted graphs. Typical users DFS remember may solve in topological sort. BFS shortest path social networks. So in the conclusion, we can say DFS great for deep exploration, low memory use, but may miss shortest path sometimes. BFS excellent for shortest paths and level by level tasks, but uses more memory. So the tip is choose based on problem requirements and graph structure. Thank you for watching. Our next video, I will explain about another important topic for you. Have a nice day. Please subscribe, comment, and share.